All right, so we're talking about slope now. Okay, moving on to slope. When you think of slope, you might be thinking about ski slope, or maybe the slopes of a roller coaster. My question is, how is rate of change related to slope? So Alexia will be selling Smencils soon to raise money for Avid class. She found out that they are made up of recycled paper. The table shows how many pounds of recycled paper is used each day of the month at the Smencil factory. So for third day of the month, there's 36 pounds of recycled paper used. The fifth day is 60, sixth day is 72, the 12th day is 144. So the first thing I want to do is I'm going to graph those ordered pairs. Make myself a little chart here. Here my x-axis is going to be the days of the month, right? Time is usually on the bottom here. It's independent. Nothing changes that. The days keep on going. And then my y-axis is the total recycled pounds. And so I plot these points. 336, 560, 672, and 12, 144. I plot those points. Next, I ask myself, is that a linear graph? The answer to that would be yes. If I were to connect these points, they make a nice straight line. So that would be considered linear. Next, I want to use 2 points to find the constant rate of change. You can use any 2 points. I just happen to use these 2 points here. 672 and the first one, 336, which was 672 is this one, and 336 was that one. What I want to do is I find the change in pounds. So I subtract the 72 and 36, done right there, which is 36. And then I also subtract the days. It took the difference between 6 and 3 is 3 days. And so I can say that they use 36 pounds every 3 days, or as a unit rate, that'd be 12 pounds per day. So what is slope? Well, slope is the rate of change between 2 points. Okay, we can write it like this. Slope is the change in y over the change in x, right? The change in how much it moved up and down versus across. So I'll show you an example here. You can choose any 2 points. I just made a little graph real quick. These are 3 different points. I can choose any 2 points. So I chose, for this first example, I chose these 2 right here. Well, the difference between 8 and 5 is 3. Difference between 6 and 4 is 2. Notice the y's is what I subtract first, and that's in the numerator. The x's is what I subtract second, and is in the denominator. So 3 over 2 would be my slope. I could choose other points. I could have chose 6, 8, and 2, 2. I do the same thing. 8 minus 2, that's 6. 6 minus 2 is 4. I can reduce that to 3/2. So since they're on the same line, they're going to have the same exact slope. Slope is also known as rise over run. You might see that, rise over run. Why? Because it's how much did it rise over how much did it run to the next point. Okay, rise over run. That's slope. Another way I like to write it in a picture form is I've been taught this in school. Rise, like the sun rising, and then this X, a little zero O right there, just kind of helps you remember of a guy running. Maybe it looks like someone running. If it doesn't, that's all right. Don't worry about it. And then the last way, I'll show you the algebraic way. So once you get into algebra, which you're getting into now, is basically they give you a formula. They say, look, y2 minus y1. It's just the y coordinates. You choose 2 y coordinates, subtract them. You divide by x2 minus x1. So it's basically saying, like, look, take a point, you take the y's and you subtract them. You take the x's and you subtract them, and you divide those differences. That would give you your slope. Here's our last example. The table shows a relationship between the number of seconds, y, it takes to hear thunder after a lightning strike and the miles, x, you are from the lightning. So I take a look at my table. Look, if I'm 0 miles away from the lightning, obviously I'm going to hear it instantly. 1 mile, 5 seconds. 2 miles, 10 seconds. 3 miles, 15. 4 miles, 20. 5 miles, 25. So I want to graph these points. I start off with graphing my points, and I look at this. I say, look, here's miles, okay, and here are seconds. This is the independent. I could be any number of miles away from the lightning strike, but the seconds it takes for the sound to reach your ears depends on how far you are. Next, I'm going to pick 2 points, any 2 points, doesn't matter. I chose 3:15, I chose this point here, and 5:25, I chose that point there. Okay, next I find the slope, the change in y. How much did it change from here to here? Now I'll show you. You could subtract in any way. I'll just show you I took 15 minus 25, which is negative 10, and then 3 minus 5, which is negative 2. But that reduces to 5/1. So every 5 miles you are from the lightning, it'll take a second to reach your ears. And so that's what we found out. Now, as you're looking at this, you might be thinking, but Mr. Ramos, I already knew that. Look, 5/1, that was our first number here, 1 mile, 5 seconds. Well, that's great. And I started off with something nice and easy. But if I were to give you only this information of the chart, right? I don't give you let's say I take this part and this part out maybe. If you didn't know that information, that might not come right away, right? Maybe you go, okay, 25 minus 15, that's 10. 5 minus 3, that's 2. 10 divided by 2 will still give you your unit rate, 5/1.